Welcome to the TCS Millable Discs demo video. Step 1. Program Setup. Open your Exocad program. Under Material, choose Flexible Denture. Go to Options and Parameters. The following pre-selected options should not be changed. Additional scans, no selection. Design support bar. Pre-selected, no. Production type of denture base. Select milling. In advanced parameters, leave the pre-selected options as they are. Major connector pattern, pre-selected leather 1. Mesh pattern, pre-selected round 1. Leave the other settings at the pre-selected millimeter values. Scroll down to the denture base thickness under teeth. This determines the thickness of the flexible material between the gum and tooth. Here, we set this to 0.8 mm. Next, adjust the denture tooth pocket gap, anterior and posterior. This controls the air gap between the pink denture base and the tooth. Set both to 0.2 mm. These are the only parameters needed to be adjusted. Click OK to save these settings. Here you can see the adjacent tooth, the antagonist, and the partial denture. Click on Design to move forward to the design phase. Step 2. Design Setup. Begin by setting the insertion direction from the view. Under Blockout Undercuts, change the Allow Undercuts setting to 0.2 millimeters. This ensures retention with a 0.2 mm undercut. If left at 0, the connection will be non-retentive. You can adjust this later to control retention. Apply the changes and you'll see it blocked out. If additional retention is needed, you can use the freeforming tool to make adjustments as needed. We won't go into details regarding the amount of undercut for now. You can also add rests here to prevent the denture from sinking into the tissue. Once you are satisfied with the blockout, click Next in the Properties window. Step 3. Placing the teeth. In this step, we'll put the teeth in place. We have the option to change the cusp height here. In this case, this tooth is very flat. The opposing side is very flat, so we make the necessary adjustments. Use the quick buttons from the Exocad program as guidance. The most important part in this section is to create the posts on the tooth. Do this by going to Attachments. Select Subtract. In Library, select Choose Parametric Design. Extrusion. Under Type, select any shape you like. For this demo, we'll use the circle. Set the radius and the height according to the tooth size and click Apply. When creating the partial denture, remember that the base thickness under teeth is 0.8 mm. So 0.8 mm will be removed from the bottom of the partial. Less than 0.8 mm, such as 0.5 mm, would make it too thin and prone to breaking. Once you're happy with the positioning, click Apply and add the same settings to the next tooth. If the teeth are misaligned, it will cause issues. Ensure they are parallel by setting the insertion direction properly and by placing it from view. Here, you can see how they are not parallel. Line them, line it up to the other tooth, and click View. If you want to add another one, you can by following the same principles. Be sure to always click View to ensure they are parallel before applying changes. Here is a very important trick. If it's left like this, the milling machine will think it is an implant screw hole. To trick the machine, use the freeform tool to smooth and round off the area. This will trick the machine into not thinking it's an implant screw hole. This concludes the tooth design phase. You can make additional adjustments to improve the appearance or add anatomical details to the teeth. Step 4. Partial design. In this view, you can see the undercut is already taken into account. Now, we simply mark the design of the partial. An important feature is the Keep Bottom and Boundary Fixed. When selected, it prevents the boundary from changing when adding or modifying areas. Ensure the underteeth mine thickness is set to 0.8 mm and the tooth pocket gap remains at 0.2 mm as we set it earlier. Explore the Blockout Tooth Pocket Undercuts feature and adjust as necessary. Click Apply to finalize. This cuts the partial into the model. At this stage, you can view the version without teeth, noting the 0.8 mm as the maximum thickness and the minimum of 0.2 mm gap. That is the final step before milling. For demo purposes, we did not get too much into detail to make it perfect. Once you are ready, save the file. Step 5. Milling the partial. Once the design is complete, it's ready to be sent to milling. It is important to set connectors in the proper placement. We recommend setting connectors slightly thicker at the material and slimmer at the partial for stronger stability. This white line indicates the height of the contour. Placing the connectors closer to the height allows more stability. For example, if we leave this connector here, there is a chance the clasp can be prone to deformation caused by drill pressure. Placing the connectors closer to the edges prevents this from happening. Add as many connectors as needed. Once the connectors are set, the partial is ready for milling. Step 6. Mechanical retention. Once the partial has been milled, we drill the mechanical retentions for tooth placement. In this case, we are using the TCS twist drill size 012. Drill one hole across the post and one on top. Be sure there is an entry and an exit. Step 7. Adding the teeth. Lastly, we add the teeth to the partial. Brush monomer to the base of the partial. Use self-curing or cold-curing acrylic. Choose any shade you like. Add acrylic to both the base and the teeth. Place the teeth on the partial and leave under pressure for a few seconds. Allow it to set. This makes the excess removal easier. The partial is now ready to finish and polish. Finally, as you can see, there will be minimum finishing and polishing due to the precision of the milling process. Experience the efficiency and precision of TCS Millable discs. Available in Unbreakable and iFlex. Thank you to our friends and partners at RF Labworks Inc. Go digital with TCS. Contact us for more information.